Hi, and welcome to Unit 2 of our pre-course learning, ground handling and signals. Much of what we cover today will make a lot more sense once you come out to the airfield and see some of these things for real. But this is the theory behind moving and launching gliders. First principle to notice is that if you see something you think is unsafe or dangerous, and even if you end up being wrong, you can call out stop, stop, stop. Everyone will listen to that. We will all respond. We'll all investigate it, and we won't continue until it's sorted out. And you'll either learn that it was safe, or we'll learn that it wasn't. So better to be safe than sorry. This is a very complex picture of all the possible bits and pieces, or many of the possible bits and pieces on a glider. Your glider that you'll train in is unlikely to have as many, but it has some fairly standard features. For example, it has a fuselage, which is a fancy word for the body of the glider. It has wings, which hopefully you can identify. It has a tail plane, so at the tail, the components here, has an elevator, which is the movable surface at the rear here. And then it has a rudder, which is also movable surface at the rear, but it's vertical, not horizontal. Ailerons can't be seen easily, but they are on the tips of the wings. And of course the canopy, which is the way in which a pilot can see out of an aircraft but not be affected by the wind inside it. Ground handling. We'll go through a few things and places you can push and places you can't push. You'll notice that when we do push a glider, we use flattened hands to spread the load. Remember that one person is in charge, but anyone can speak up. If you see something's not right, call stop, stop, stop. Only one person holds a wingtip. We don't want to have contrary or incorrect loads on wingtips. The length of the wings can cause damage at the body when pushed incorrectly. So although you might have a person at each wingtip, only one person has contact with the glider. If you want to swap control from one wing to the other, you can say your wing and the other person responds by saying my wing, or somebody can take control by saying my wing and the person who was in control can respond by saying your wing. It's so that we know who is actually stabilizing the glider with the wingtip. In pushing the glider, never push against the tail areas at all. Leave those completely out of bounds when pushing. And anything that moves on a hinge, don't push against any of those either. Don't push against the wingtips either. Don't try to force the glider to move on its axis by use of the wingtip. There are better ways of reducing the forces at the wing roots. And although you will provide gentle steering loads on the wingtips, usually while the glider is in motion, don't hold the winglets as they are a weak component. So to push, you can see the green spots here that you can push over the wing spar and over the center of the fuselage. You can also push against the inboard leading edge if you're moving it backwards, or against the nose. If you fit a tail boom, fit a dolly to the tail boom, the glider can move on a rotating wheel. Otherwise it can be lifted to turn the glider. The tail is lifted to turn the glider. If you push down on the nose, some gliders don't let you push on the nose, but if the glider can let you push on the nose, then that can also help ease the amount of weight required to lift the tail dolly to turn a glider. That's just a summary of the entire slide. Turning a glider. Gentle pressure on a wingtip will turn a glider in motion. Never try to push a glider to turn it unless the tail is up. You can balance on the main wheel so you can turn sharply, and the main wheel rotates on its point provided the tail plane is lifted. But if you have a tail dolly, then of course you can turn quite easily if it's fitted. People on the other wings, or pushing or pulling, no pulling, just pushing, can keep a lookout, especially when they're close to other objects. This is a picture of tow-out gear. When you have an ideal situation that requires less helpers, then that can also be helpful because you've got less people getting in the way and less people trying to work out where everyone else is going. So this is an example of a glider being used with a tow-out bar, a tail dolly, a wing dolly, and can be handled quite easily. But if you do want to move ground handling using tow ropes and a car, if you don't have tow-out gear, you notice here's the minimum people required and their positions, and also the driver, of course. And the driver needs to be able to have visibility and also communication, so they drive with their window down. If the wind is strong, don't move the glider. Secure it until it's safe. If there's tailwind, you might want to lock the cockpit controls. So inside the cockpit, you may be able to secure the control column so that it doesn't flap in a tailwind. You need to have a long enough tow rope. 2/3 of the wingspan is a minimum, so that if the glider does overrun slightly and turn off to the side, the wing does not collide with the vehicle. If you have to attach or detach the rope length, please lift the canopy to pull the release knob. Never operate anything through a canopy except the canopy release mechanism. So the tow plane release mechanism has to be done with the canopy up. This prevents damage to the canopy of the side vent, clear view, and there are plenty of gliders around that you'll see with cracks where people have not followed this instruction. The driver should only go at walking pace, so listen out if they're telling you to slow down if you're the driver. One person holds the wingtip, into wind preferably, steers the glider. If there's no tail dolly, you'll need to stop the glider and lift the tail dolly to set a new direction to follow the car, especially if it's going around corners, etc. The person in front of the wing will stop the glider overrunning the rope. We don't want to get entangled in the main wheel. And the wingtip person is only required here if you're moving close to other objects on the other side to help maintain good clearance. All can look out for obstacles ahead, scan for directions for air and ground traffic. Summary of the whole slide there. Gliders should be tied down when not in use, especially if they're unsupervised and especially in a strong wind. You remove the tail dollies so that they don't get the glider spinning around in the wind. Wing weights are sometimes used to stop wings lifting on the ground, and always close canopies when walking away for a glider. A canopy is either open and held or closed and locked. Here's a picture of some hardware we use. At the top left here, you've got the release mechanism that is inside the glider nose or under the belly. In this ring here, you can see that is where the tossed rings are attached. This is the small ring that would go into this section here. You can see here is connected to a rope by means of a weak link and to the tow plane, and this one here is connected to the glider. Weak links are also employed when using winch launching at a glider end. This is the deconstruction, if you like, of the components of the weak link. This is to ensure that if a strong jerking force is on the rope, it does not damage the glider, it just breaks the link, like breaking the rope. So if you have a bogged wheel on takeoff, or you're too low in low position, low tow, or you get a jerk or a rope catches on a fence, this weak link will break and save the aircraft from overstress. And when we're launching a glider, here's what we have as a picture overall. The tow plane, of course, the weak link at the tug end with a rope that's at least 55 metres. Our glider operations are 70 metres long. The ring in the aerotow release. The glider pilot has his hand near the release handle to release an emergency. The wingtip runner controls the launch, and possibly there might be a forward signaller up here that the tow pilot can see to relay the wingtip runner's instructions. We also use radios to give those instructions so that the tow pilot can hear them over the radio. Once the pilot has completed his pre-flight checks, which we will cover in a subsequent slideshow, the crew will ask, "Pilot ready?" The pilot will respond, "Pilot ready." The crew will have him recheck canopies, to which the pilot will respond and check, closed and locked. Crew will ask, "Air brakes?" Pilot will respond, "Closed and locked," and check. Crew will look across the aircraft on the wings and on the tailplane to see if there are dollies attached. If there's nothing attached, the crew will say no dollies. At closed and locked, the crew may also ask radio frequency set correctly and use the acronym CARD to remember canopies, air brakes, radios, dollies. To hook on, the crew confirms the pilot is ready to hook on as instructed in the previous slide. He then shows to the pilot the small ring. He gives the open hand signal, which is an open hand, and says the word open, and then inserts the ring into the release mechanism at the nose of the aircraft for an air tow, underneath the belly for a winch launch, and then closes his hand into a fist and says close, and the pilot then releases or lets go of the tow release, and the rope should stay. The crew can rattle the ring to be sure that it is actually connected inside loosely, and then put some tension on the rope to be sure that the ring is in correctly and will not pull out on a small amount of tension. Launching, checking the airspace. The crew then looks all around for any traffic ahead, behind and each side, and looking for possible conflicts, landing, aircraft taxiing onto the runway, that sort of thing. He can delay the launch until airspace is clear. But if it is clear for launch, he can point out the aircraft that might be around that he wants to monitor and say airspace clear for launch. Launching itself. The wing runner moves to the wing tip. He waits for thumbs up from the pilot. He lifts the wing and gives the tape up slack signal, which is swing the arm across the lower body, like a pendulum motion of a grandfather clock. The wingtip runner and forward signal where used should be checking the airspace is clear during the taking up of slack. This can take a few seconds. When the rope is tight, you give the all-out signal, which is you swing your arm above the head in an arc, drawing or painting a rainbow. You hold the wing lightly and run a few steps until the wing lifts out of your grasp. Do not grip or restrain the wing at this point. You can use your hat or baton and make your signals large and obvious. Some clubs may use a radio in place of signals. So just to refresh, the take-up slack is to swing the arm across the lower body. The all-out signal is swing your arm above the head. However, if something looks like it shouldn't be happening, you say stop, 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 raise the arms above the head. And remember, anyone can say this and stop the launch. The response of a stop launch is best done before the all-out signal is given, or at any situation putting the launch at risk it's very difficult to stop a launch once all out has been given. You shout stop, stop, stop. You raise both arms above your head, put the wing on the ground if you've heard the signal, or if you've made it, you can put the wing on the ground after you've made it. Hold both arms up in the stop signal, palms forward. The pilot releases the tow rope on the call of such a signal so that the launch cannot proceed. In summary, we have glider components, the different parts of the glider which you can review. We've got pushing gliders, turning gliders using tow out gear, the different hardware we use, and tying down gliders. We've got launching, the crew checks, hooking on, checking for clear airspace, running the wing, using signals, which are take up slack, all out, stop, stop, stop. If you have any questions, please remember to send us it or ask your instructors at the airfield.